In this video, you will learn about solving systems of linear inequalities. First, let's review the steps to graph a set of linear inequalities. First, you need to solve to get y by itself and graph the boundary line and shade the appropriate regions. Now, if it's a greater than or equal to or less than or equal to, you're going to shade a solid line. And if it's greater than or less than, it would be a dashed line. And if you have a greater than or equal to or greater than symbol, you're going to shade above. And if you have a less than or equal to symbol, you would shade below. The solution set is the part of the graph that is the overlapping area. And every point in the shaded area has to satisfy both inequalities. And we say in this case that a system of linear inequalities has a solution set, rather than just having one point that is the solution.
As a reminder, it's very important that we remember how we determine our different types of lines. If we have a situation where it's just greater than or less than, use a dash line, versus if it's greater than or equal to, use a solid line. And then also, if it's greater than, we would shade above, versus when it's less than, and it looks like that tilted L, you shade below. To solve this example, I first have to solve to get y by itself for both inequalities. So my first inequality is 2x minus y is greater than negative 3. Now to solve to get this y by itself, I first had to move the x over. So I would subtract 2x from both sides. So I get negative y is greater than negative 2x minus 3. Now if I want to finish getting this y by itself, we see that there's this negative in front of the y, which means there's really a negative 1. So I'd have to divide everything by negative 1 to get y by itself. Now when I do this, this becomes y, this becomes 2x plus 3, and then we have to be careful of the symbol to determine how my line is going to be graphed and go from there. So because of the dividing by a negative, remember you flip the sign when you divide by a negative number. So because of the fact that this negative 1 is negative, this means that we are going to flip the sign. So instead of being greater than, it becomes less than. And now I can graph this line. So I would have a slope of 2 and a y-intercept of 3. So I start at 3, and we know my slope of 2 is really 2 over 1. So I can go up 2 and over 1 and add in my extra points. And then based off of the symbol, because it's less than, we know that we're going to use a dashed line because it can't equal it, and you're going to shade below. So I can draw in my dashed line and shade below. For my other equation, I start with 3x plus y is greater than or equal to negative 2. So to get y by itself, I start with y. I'd have to move the 3x over. So I subtract 3x from both sides. So these cancel. So I get y is greater than or equal to negative 3x minus 2. And now if I check, there's nothing else with the y, so this is already all set to graph. For the other part of the example, down here I get my slope is negative 3 and my y-intercept is negative 2. So I would start at negative 2. My slope of negative 3 is really negative 3 over 1. So I would go down 3 and over 1. And I can add extra points to cover the whole graph. So I'd have a point here and here. Now because the symbol is greater than or equal to, this means you're going to use a solid line and shade above. So I would draw in my solid line and shade above. Now the solution is the intersection of these two areas, so my solution would be this region here, which is shaded in both red and blue. For the next example, you again have to start by solving to get y by itself. So I have 2x minus 3y is greater than or equal to negative 9. Now to get y by itself, I have to start by moving the x. So I subtract 2x from both sides. So I get negative 3y is greater than or equal to negative 2x minus 9. Now to finish getting this y by itself, I have to get rid of the negative 3 in front, which means I'm going to divide. So I would divide by negative 3, and negative 3. So this is going to become y. The negative 2 divided by negative 3 becomes positive 2/3 x. And negative 9 divided by negative 3 becomes plus 3. And we have to go back and check to see if I need to flip the sign. Now, because of the fact that these numbers are negative, meaning the number we're dividing by is negative, this means that you're going to have to flip. So it's negative, so you have to flip the sign. So instead of being greater than or equal to, it becomes less than or equal to. So if I were to graph, I have my slope of 2/3 and my y-intercept of 3. So I can start at 3, go up 2/3, and add in my extra points to cover the whole graph. And then based on the symbol, because it's less than or equal to, it means it's going to be a solid line, and you're going to shade below. So I can draw in my solid line, and I would shade below. Now for the next one, my original inequality was 2x plus 3y is less than or equal to negative 3. So I start to get the y by itself, I again have to move the 2x. So I would subtract 2x from both sides. So these cancel, and you get 3y is less than or equal to negative 2x minus 3. And then to finish getting the y by itself, I had to get rid of the 3 in front. So I would divide everything by 3. So I get y. This becomes negative 2/3 x minus 1. And because of the fact that this is the numbers we're dividing by is positive, we don't have to flip. So it's positive, so no flip. So my symbol is going to stay the exact same as less than or equal to. So now if I want to graph, I get a slope of negative 2/3 and a y-intercept of negative 1. So I'm going to start at negative 1, go down 2/3, and I can add additional points in the other direction. And then because of my symbol, it's less than or equal to, so this means I'm going to use a solid line and shade below. So I can draw in my solid line and shade below. So the solution is the intersection of these two regions. So my solution would be this whole area, which is covered in both red and blue. As a reminder, there are some special cases we have to be aware of. If we look at the first example, I already solved and graphed the two inequalities. However, we can see that the intersection is just this small area right here. So your solution would be just this area here, outlined by this solid line and this dashed line. For our other example we have here, we can see that after they're graphed, the intersection is just this top area over here. So our solution would be just this area with that dashed boundary line. And in our last example, we can see that there isn't an intersection at all for these two inequalities. So this would technically have no solution. So again, we have to be aware when we see special cases where there's parallel lines, what our different types of solutions may look like.